So, trying to find the acceleration of this entire system. What's a smart system to take? What two things do I take for my system? M1 and M2, right? Now, this axis is bent over here. So up here, my x-axis goes along the rope like that, right? My y-axis is going to go perpendicular to the x. That part make sense? Down here, my x-axis goes down along the rope like that. So my y-axis goes perpendicular to the x, like that. Bless you. All right, I know this looks weird. I know you're not supposed to do this, but trust me, this is fine. It works. All right, everyone okay with the coordinate system? Again, practice, practice, practice. Eventually, this will start to make sense. If you're just watching me do it, I can tell you what the correct answer is, but, you know, and you're struggling, I do have office hours before this. Come, ask questions, all right? Usually I'm just in there talking about random stuff, so bring your physics homework. I want you to pass this class, but you guys have to get this stuff, or else 4A is going to murder you guys. Or 2B, if you don't know what I'm thinking. All right, f of x. What forces are in the x direction that don't cancel out? Friction, right? Minus mu k times the normal force. The friction from here. Make sense? What other force is in the x direction? Weight. That points down like that, right? And that's a plus or a minus? Right? Positive M2G. Oh, okay. I'm calling this M1 and this is M2. And what does this all equal to? M1 plus M2 times the system acceleration A of x, right? Yes.
Normal force for M2 not apply in this equation?
There is no normal force for M2 because there's no surface.
Nice.
Yes. All right. This x equation makes sense? Remember, this weight points down, but we're defining down as positive, so that's why it's a plus 2 mg. This is our axis now. All right? Everyone clear so far? F of y. What y forces are there?
M1.
So N1 minus M1G, right? The weight and the normal force from block 1, and nothing for block 2, right? Because there's no forces going in the side-to-side direction over here. Making sense? And what does M1 minus M1G equal? M1 minus M1G equal to? 0, right? All right, this system equation makes sense for you guys? Yes? Any questions? Seriously, ask now. Great. All right, so I have to, unlike the example problem, I actually have to use my y equation over here because ultimately I'm trying to solve for a of x, but I don't want this m1 here. So how can I use my y equation to eliminate this end of m1 over here? What's m1 equal to? M1G, right? We're going to plug this M1 back into the x equation. So we get negative mu k times M1G plus M2G equals to M1 plus M2 times the acceleration. Does that make sense? Great. Now to solve for a of x, I just divide both sides by the mass. So this becomes M2G minus mu k M1G over M1 plus M2. Clean this up to make it a little bit more pretty by factoring the G out. Again, you don't have to do this. It's just style points, but style is sometimes important. So that's going to be 4 minus 0.55 times 5 over 4 plus 5 times 9.8. So you get 1.36 meters per second squared. All right. Is that clear to everyone? Now, one final thing you should do before moving forward with a problem. Your acceleration should always be positive over here. Because this is a vector, right? That means if your acceleration is positive, which way is your system following? In the positive direction, right? So in the direction you predicted. If it's negative, that means it's going in the direction it's going against your guess, right? Your guess was wrong. Now, sometimes you can just flip the negative sign and they'll be totally fine. But if you have friction over here, that changes your entire problem. Because if your system was sliding this way, like that, then your kinetic friction will be pointing like that instead of to the left, like this, all right? So always make sure whatever you solve for, your acceleration is positive. If it's not positive, redo the problem, check your work, because it's probably not correct. Yes. All right, it's making sense. Everyone feeling okay? Again, what are we gonna do between now and tomorrow? Practice this, right? Problem set 6. It's a long problem set. Get started on it, all right? Sooner rather than later. I'm not joking when I say this. Like, if you don't get this, 4A is gonna murder you. All right. So that's the part A, that's the acceleration. For the tension, you have two choices. You can choose M1 as your system or M2 as your system. Which is easier? All right, M1, let's see. We got a tension force here and we got a friction force here. Cool. But for M2, we have the weight and we have the tension force. Usually go for the weight, because the tension force, you have to plug in normal force again and do all that song and dance. If we choose M2 as a system, so we choose M2 as the system, then my tension force points up and my weight points down, and I'm accelerating downwards like that. So my x equation becomes negative t plus m2g equals to ma of x. So t is equal to m2g, negative m2g, plus m2a of x. So t itself is just equal to m2g minus m2a of x. Factor that out. So that's 4, 9.8 minus 1.36, and that's 33.8 newtons. All right. If you choose M1, you can still get the same answer. It's just friction tends to be a little harder to work with than the weight. Either one is fine, because the tension in the rope is constant. Yep. Making sense, this problem. Again, I can do a lot of these problems for you. It's fine. I don't mind it. Maybe it's maybe easier, but you have to do this yourself to understand it. All right, practice, practice, practice. That's the only way you're getting across. And if you're still struggling on it, seriously, hit me up tomorrow. I will explain this to you in excruciating detail. I can do that.
It's a date and
Okay, don't call me that, but. Okay, any questions on this? Good? Yes? All right. I'm gonna do the homework problem now. So that's problem set 6. All right, and then we'll take our last break and then we'll start the new module. So, as you can see, the homework is extremely similar to these problems. This one is the same problem as the train one, except your force is at an angle. Hopefully that's not too hard at this point. This one is exactly the same problem, with the numbers changed. This one's the block on the ramp. So this combined the problem we did before with the complex system stuff. Again, hopefully not too difficult. And, ooh, this one's kind of fun. All right, so your homework for tonight, pacing-wise, get through these first 3 problems, all right? Try to get through it. All right, let's do this. Ooh, this is fun. Let's do this one. 2 ramps. All right. Again, these things are recorded and posted, so if you need some extra clarification, I'm always here in spirit. All right? When you can't sleep at night, you know who to turn on. Hey guys, welcome back to yours. Some people do use those videos to fall asleep, you know, but apparently sometimes I randomly crash out in the middle of class and that wakes them up and then they get mad at me about it. Say, why do you scream at minute like 38 seconds over here? I was trying to sleep. Okay. Alrighty, this one. Cool. So, you have 2 ramps essentially. A 20-degree ramp and a 60-degree ramp. First thing to write down. This is a parallel line. This is another parallel line, right? And this is the transverse line. Alternating interior angles are congruent. If this is 60 degrees, this also has to be 60 degrees. Does that make sense so far? All right. I wrote this on yellow paper, so it means it's important. So. Yes. 615. 24 5478. I don't know. Try it out. I don't know. Try to steal my identity. Open like 10 bank accounts in there. Maybe it works. Maybe you get bombarded by the IRS for identity theft. Life's a gamble. All right. So, same concept here. You have 2 blocks. Part A says determine the magnitude of the tension in the rope. Before doing that, what do you need? What should we always solve for first? Acceleration, right? So, spoiler alert, this thing is going to fall down like this. So, my coordinate system, my x-axis, is going to go down the rope like that. That comfortable for everyone? Yeah. All right. We're going to take, and this is part A. We'll do part B probably tomorrow. We're going to take M1 and M2 as a system. All right. So let's think. What's the one force that cancels out here? What's the action-reaction pair? The tension, right? Because as the 2 kilogram block pulls down on the 4 kilogram block using tension, the 4 kilogram block pulls back up on the 2 kilogram block, right? Okay, that's good. What other forces, and let's do a force table for this one. Because it's What other forces are acting on the two blocks? Let's call the 4M1 and the 2M2. Let's start with M1 first. What forces are acting on M1? Weight. So W1. What else? Normal force M1. What else? Friction, right? Fk of 1. That first part makes sense? All right, so this is for block 1 or M1. All right, what forces are acting on M2? Weight, normal force, and friction, right? All right. Excellent. So this will be M2. All right, now let's start breaking this apart into components. So this is a rotated coordinate system now. So for M1 over here, let me draw that out. For M1 over here, that's a 20-degree ramp. M1 looks like this. Weight points down, normal force points perpendicular, and static kinetic friction points up the ramp. And we're defining positive x as down the ramp. So let's do the easy ones first. For the friction and the normal force, the friction just goes along the ramp, right? So that's in the x direction. So that's just minus mu k times m1, right? And 0. Right? See how it's coming back to the block on the ramp stuff? For normal force, that's 0 in the x direction, and perpendicular ramp, that's just m1, right? The weight, that's this angle over here. Let me redraw it. Like this. Here's WY and here's WX. What goes in the X and what goes in the Y? So what's the X component of the weight vector in this rotated coordinate system? Sine, right? So that's M1G positive because it's pointing down the ramp. Sine 20 degrees, right? Make sense? Or the Y component? Minus M1G cosine 20 degrees, right? Everyone see that? This was just the same as the original block of the ramp problem we did. We're just putting it all together now. Do okay? All right. And here's the nice part of this problem. The second mass is also a block on the ramp, with just a different angle and some different numbers. So you can literally copy this part over here and just replace it with the appropriate numbers. So for this, we'll call it M2G sine 60 minus M2G cosine 60, 0 and 2, negative mu k, and 2, and 0. And this is what I mean about this problem. This type of problem is hard until it's not. There's only so many variations I can put, types of problems I can put of this type of problem, right? Sometimes it's like adding a ramp, sometimes adding friction to the ramp, sometimes it's like adding another block, but the problem solving strategy remains the same, all right? So that's why it's important to practice those scenarios, because every time you're practicing, you're solving a similar problem to these, and you're building up the intuition. When you see a slightly different problem like this, it's going to be easy or less hard. Okay, this force table makes sense for everyone so far.
Yeah.
Good? Feeling okay?
Yes.
Okay. Falling asleep yet?
No, not yet.
Okay. So we can go to 11, right?
No.
Aw, cowards. You should be like, yes, professor, we should definitely do it. Yep. All right, so we're just copying down all the x equations. And all the y equations. So let's see. Hang on. Oh, one difference here. For block 2 over here, if this thing is sliding down the ramp, which direction is the kinetic friction? Up the ramp, right? So that will be negative, right? Okay, negative, that's good, negative, that's good. M1G, M1G, that's good. Okay, I'm tripping. Minus that, plus M2G, sine 60, minus mu K, M2G, welcome to physics, cosine 60. And all of that equals to what? Two times the acceleration, right? So that's the x equation. So it's a lot of stuff, but hopefully you saw how we built up to it. All right, that was the x. Now let's take a look at the y. So the y, that's m1 minus m1g cosine 20 plus n2 minus m2g sine 20. Cosine 20. Again, 60. Just copying down. And this is equal to 0, right? Because you don't have any acceleration perpendicular to the ramp. Oh, sorry, jumped the gun here. This is M1, and this is N2. I can only go fast. But that's a great answer. First time I taught this course, we finished all the material in the course by so it's a 15-week semester, right? We finished all the material in the course by week 12. And apparently I was going too fast. So I go slower and slower and slower every semester. So maybe by the time I teach this course for the 20th time, we'll still be on kinematics by this point in the semester. Teaching is a journey, not a destination. All right, these two equations make sense so far? All right, now we're trying to find a of x, right? So we're going to start with the x equation over here. So start with the f of x equation. And to make your life a bit easier, start grouping terms together. So we're going to group the m1g signs together. So this is m1 sine 20 plus m2 sine 60. And we'll just pull the g out. So that's this term and this term over here to give us this term. And we'll group the mu k's together. So factor out the mu k, so this becomes m1 plus m2 equals to m1 plus m2 times a of x. So that's this green term over here. Bless you. Making sense so far? All right, now, what term is bothering us over here? This n1 plus n2, right? Remember, friction problems, we rarely care about the normal force. So how can we solve for n1 and n2? Which equation do we have left?
Y.
Yep. So using f of y, we can see that m1 plus n2 is just equal to m1 cosine 20 plus m2 cosine 60 with the g factored out, right? Bless you. You guys getting sick?
I was just thinking that, dude. I was just thinking that.
Okay. Don't worry. Last semester, I had like 4 different students independently go to the ER for various issues. So.
Immune system just get stronger.
Too much cortisol.
Yeah. All right. After N1 and N2, we can plug this back here. So let's, loop. So this is a lot of writing, but hopefully you are keeping up. And if not, you got a night to practice. Cosine 20 plus M2 cosine 60 times G, and that's equal to M1 plus M2 times A of X. All right, so now you just divide by the system mass, and you are home for the acceleration at least. Okay. M1 plus M2 with the G factored out. Again, if this is looking completely foreign to you, practice it. All right? It's the only way you're getting out of this. So, we just have to plug everything in now. So, that's 4 sine 20 degrees plus 2 sine 60 degrees minus 0.2 for cosine 20 plus 2 cosine 60. 4 plus 2 is 6 times 9.8. Happy Monday.
Thank you.
Remember the first day? It was so nice. It was like, oh, yeah, let's just take this number and subtract it from this number. Oh, you did that. Good job. Yeah, this is what this class is really about. And then after drop deadline passes, we get to the really, really hard stuff. No. Actually, yes, but that's not the reason why the drop deadline exists. I'm not that evil. Okay, you guys remember how I was nice to you like up until now? Okay, turns out I'm actually evil, and this is a.
You're the Joker of physics.
Exactly. All those good Rate My Professor reviews were made before the second exam.
You wrote all the reviews.
He did. He bought reviews.
3.51 meters per second squared. This is the real me.
No, the real you is in Discord.
Yeah, that's accurate.
You need to find him.
Okay, so I know this problem, it's really, really long and kind of hard, but again, practice. All right, we found the acceleration. Now we can find the tension. Okay.
Yeah, this is the part where you're going a little faster. Like, he was writing. I can't even breathe. I think I'm just gonna hop on the left and come in and blow it out. I think about it tomorrow. I think about it still. No, we don't. Our homework's due on Wednesday.
This is 2% of my full power.
Cap.
So by week 5, do we do sound?
What?
By week 5, do we do sound?
Yeah, eventually. It's basically like what a decibel is. That's it.
Do you listen to Radiohead in that week?
Yeah, sure. All right, everyone okay with this? Okay. Why did I take this class?
Because it's required. Dude, I might as well just be an engineer. My first step.
Yes. Okay. May I continue?
Yes.
Cool.
You have permission.
Oh yeah. Thank you for giving me that. All right. Nice part of this problem. After you solve for the acceleration, the rest kind of just falls apart. So, yay. Okay, so same deal as before. We choose a simpler part of this system. Should we choose M1 or should we choose M2? It doesn't matter. They're both equally hard.
Could we flip a coin?
Let's do one.
You chose the harder one.
No, they're both equally hard. Or easy. Alright, we're gonna choose M1 as a system. You guys are way more funny than my last class.
Papa
And that's because like, there's so much going on in my life. Why are you taking this class?
How old are they?
What?
How old are they?
Older than you guys. It's weird.
Millennials. Ugh.
Oh, he dated back to the dinosaurs?
That's okay. Most of them are all right. Oh, wait. I respect all students equally. I'll just say this crap now. If we really get to like week 5, I'll tell you all the stories that happened last semester.
If we get to week 5.
Yeah, if.
You guys find some new variables.
All right, here is the free body diagram for the first block. All right. So. Friction, weight, normal force, tension. In the x direction. So hopefully this is a little bit familiar now. If not, again, the P word. No. All right. Everyone okay with that? So f of x, negative mu k times n plus mg sine 20 plus tension equals to m1 a of x, right? F of y, n minus mg cosine 20 equals to 0. All right, here's how to do that. Finish the test in 50 minutes. Finished it in 50 minutes. So here we're going through the full steps, right? We're writing f of x and f of y. In truth, for these problems, the f of y equation is only useful to give you the normal force. So if you're really, really fast about it, and you saw this equation, you could directly just write negative mu k times mg cosine 20. If you're comfortable doing that, that's totally fine.
Thank you.
But if you don't, you can always go through this process. And then solve, substitute, and isolate. I should do it MSM. It was it MSMR, ASMR physics. Hey guys, today we're doing free body diagrams, and then do like some of this, you know, this stuff.
No, you should do physics mukbang.
What's a mukbang?
You don't want mukbang?
I don't know what mukbang is.
You watch other people eat.
Mukbang.
Mukbang.
She corrected me. Mukbang.
I say mukbang because
Okay, how's it actually said in Korean? Mukbang. Yes.
well, they were originally created for people who like had no life, like no family members. So they played.
That's so sad.
I'm so serious. So they made those videos where they can eat with people.
Okay, I saw the saddest video like last night. So this South Korean this South Korean AI company, VR company, recreated this mother's dead child as a, so she was it's not, I'm laughing, but it's not funny, alright? So she'll be wearing like a she'll be wearing like this like Oculus Rift, right? And then it'll be this like AI child. It's like, oh ma, and then she'll be crying. And it's like, oh, by the way, charge her like $500 per hour to interact with this AI version of Dead Daughter.
No, I said sad one. I would have been like, scroll.
I know it's sad, but the fact that it's actually happening is kind of disturbing. I'm not laughing because it's funny. I'm laughing because it's ridiculous. Okay. Anyways. Okay. 1 more hour. I can crash out now.
Yeah. Wait, it's raining, right?
Yes. All right. Tension solved. So let's see. M1 G. Okay. Mu K. Cosine 20. Sine 20. Plus A of X. I'm laughing, but it is literally the most messed up thing I've ever seen. I see a lot of stuff on the internet.
Top 10.
No.
Number 1.
Like you guys are making fun of it because it's abstract, but seriously, watch that video.
No.
How much extra credit?
None.
0.5 extra. You should just make the extra credit like 0.25. So like
No.
by the end of the next year, it's just 2 extra credit points.
All right, plug and chug 8 newtons. All right, this makes sense. Again, if this is, I know it's very long, but it's basically a bunch of problems we solved before just put together. All right. So, what are we gonna do between now and tomorrow? Practice, right? Please. I'm not telling you to go do your homework, but you should really do your homework. All right.
Dude, imagine having a mute when you got good.
Okay. Any questions on this problem so far?